We are going to talk about supervolcano. What is a supervolcano? What is so special about supervolcano that we cannot just call it as a normal volcano? Well, simply because it is not normal. Supervolcano is a volcano that have an eruption on a massive scale. We know that volcanoes are abundant, but there are only about 20 known supervolcanoes on Earth. The largest supereruption happened 2.1 million years ago at Yellowstone, and the most recent supereruption happened 22,600 years ago at Taupo in New Zealand, which has now become Lake Taupo. Supervolcano is different from a normal volcano in terms of its characteristics, volcano explosivity index, and also the frequency of the eruption. Supervolcano have features called caldera, which is a bowl-shaped depression that forms when a volcano collapses after a magma chamber is emptied. It also has a ridge of higher land around it. This is different from a normal volcano because they usually have a cone-shaped structure. In terms of volcano explosivity index, which is an index to measure the scale of volcanoes' eruption, supervolcanoes have a VEI of 8, which is the highest rank of the index. This indicates that they at least release 1,000 km³ of deposits into the sky. As for normal volcanoes, they only have a VEI that is lower than 8. Supervolcanoes erupt less frequently and they erupt 100 to 1,000 years apart compared to a normal volcano that erupts more frequently. There are 3 stages of forming a supervolcano caldera. The first stage is a surge of magma that involves a magma chamber that is trapped inside the Earth's crust, which we call a hotspot, and it is attached to the Earth's molten interior by a pipeline. It will eventually grow and build pressure underground, causing the upper crust to be pushed upward, forming a bulge. In the second stage, which is supereruption, the pressure reaches a critical point where the Earth crust can no longer bear, leading to an explosion that can at least reach 1,000 km³ of material or deposits released into the sky. Lastly, resurgence occurs where the magma reservoir collapses after being dispelled from the explosion, thus forming a feature that we call as a caldera.
So my name is Hania Zulaika and I'm going to answer these questions. If there are any active supervolcano, how many are there? And if there are any, are we in danger? Based on my readings, there are about 20 known supervolcanoes on Earth. This include Lake Toba in Indonesia, Lake Taupo in New Zealand, the biggest supervolcano in the world that had many knowns, which is Yellowstone, that located in Wyoming, USA, and many more. These supervolcanoes are still active. The lead author, Wim Melfeit of ETH Zurich, said, "We knew the clock was ticking, but we didn't know how fast the clock's ticking." Based on this sentence, these supervolcanoes somehow going to erupt soon, but we don't know when. Supervolcano is not just a regular or even the biggest volcano in the world. Super, it's just super. You might think of these kinds of volcanoes are only existing in prehistoric times, but you're wrong. On January 2017, scientists reported that Italy's Campi Flegrei, that a volcano in the metropolitan area of Naples, shows signs of waking up and approaching critical pressure. These volcanoes are still active, might be erupted soon, but we don't know when. The clock is ticking, but we don't know how fast it is. Are there any supervolcanoes that threaten life in modern areas? The answer is there are 6 possible supervolcanoes that are going to erupt soon. This one includes the Aira caldera in Japan, the Lake Toba in Indonesia, and also the Yellowstone. If these supervolcanoes are still active, are we in danger? So, a volcano doesn't need to have to be a super eruption to be dangerous. If people are nearby as the volcanoes explode, even small eruptions pose many hazards to people around the volcanoes. With that said, not all volcanic eruptions are dangerous. For example, if an eruption takes place far from population and flight path, no one may even notice that the pit bursts at its top. So, if the eruption happens far from people, we ourselves might not even notice. So, as conclusion, there are still active supervolcanoes on Earth, and is it dangerous? Yes, if you live several kilometers away from supervolcano. So to make it not dangerous, live far from the volcanoes.
So, what makes a supervolcano super? There used to be some misconception about them, considering their massive eruptions do cause real dangers in the past. So, according to the USGS, for a volcano to be called super, it has to have the potential to eject more than 1,000 cubic kilometers or 240 cubic miles of volcanic material. That is 1,000 times greater than any volcanic eruption seen by modern humans. A dead giveaway of a volcano's potential to be super is hidden deep within the Earth's crust, where an enormous chamber of magma forms because of incredible heat, 2,500 Fahrenheit, rising from the Earth's mantle. So that places a magnitude of 8, the highest ranking on the Volcanic Explosivity Index, or we call it as VEI, which is used to measure the explosiveness of an eruption. So the explosivity value depends on the volume of products, the height of cloud eruption, and other qualitative observations. So for example, as you can see that Yellowstone caldera has been classified as VEI 8 based on the qualitative observation that has been done. So moving forward, the impacts of these very large eruptions is very widespread, from avalanches of hot rock and gases racing down the volcano's flanks to global changes in climate. But there's an important caveat about supervolcanoes that most people commonly overlook. Just because a volcano has had a super eruption once or even twice in its past doesn't mean its future eruptions will be just as big. What's more, very few volcanoes reach such a super status. For example, some 5,000 eruptions that occurred during the last 10,000 years. When we apply the VEI to know on the degree of the eruptions, not a single one are ranked a VEI 8 according to the SGS. While dozens of volcanoes may be erupting around the world, on any given day, scientists have identified just 42 eruptions that ranked a VEI 8 or high 7 in the last 36 million years.
What type of volcano is Yellowstone? The Yellowstone supervolcano is located above a continental hotspot and is morphologically classified as a caldera. So what is a caldera? The term caldera originates from the Latin word caldaria, which means boiling pot. According to Cole, Jim and Milner, a caldera is defined as a volcanic structure, generally large, that is resulted by the collapse or subsidence into the top of a magma chamber during or immediately following an eruption. Let's look on how a caldera forms. A caldera can be formed as a result of a super eruption. Violent eruptions occur when the pressure builds up due to trapped gases. When it happens, the magma is ejected rapidly through the vents and the magma chamber becomes empty. The lack of magma reduces the support of the overlying rock and will form an area of weakness, causing the rock body to collapse. We can see the empty spaces in magma chamber after an eruption and the rock collapsing as a result of it. Next, we can see some features of a caldera, such as the caldera rim and a topographic low. In this picture, the caldera rim is the steep wall which is about 500 meter high. The highest elevation of Yellowstone caldera, however, is actually much higher, about 2800 meter. Besides the rim lies an area of topographic low, which can become a lake or a river channel after catching water. Here is another picture of the caldera rim and the topographic low beside it. The picture on the right is another feature of a caldera, which is a resurgent dome. This picture specifically shows the Sour Creek resurgent dome. There are three major calderas surrounding the Yellowstone hotspot. First is the Island Park caldera. It is outlined in blue color in this picture. It covers approximately 5,200 square kilometers, which makes it the biggest caldera in that region. The caldera is formed by a super eruption that occurs 2.1 million years ago, and it is estimated about 2,500 cubic kilometers of volcanic material is ejected. As a result, Huckleberry Ridge tuff is formed from the volcanic ashes. The next big major caldera is the Henry's Fork caldera. It is the one in the corner over here, but also notice the two resurgent domes here. One of it was mentioned earlier just now as the Sour Creek resurgent dome. The Henry's Fork caldera has an approximate area of 1070 square kilometers, which is relatively much smaller. The eruption for this caldera occurred 1.3 million years ago, and about 280 cubic kilometers of volcanic material was ejected. The volcanic ashes of this eruption form the Mesa Fall tuff. The last one is the Yellowstone caldera, which is outlined in purple color. Its area is approximately 3,960 square kilometers, and the eruption occurred 630,000 years ago. About 1,000 cubic kilometers of volcanic material is ejected, and lava creek tuff is formed as a result. You can also notice over here that the Island Park caldera and Yellowstone caldera overlaps. The three examples shown just now are formed from Plinian type eruptions. Plinian type eruptions are characterized by columns of volcanic debris and gases ejected high into the stratosphere. This is proven by the spreading of volcanic ashes over very far distance towards the eastern and western part of USA. There are also smaller scale calderas scattered around Yellowstone as a result of volcanic activities, but I just went through the major ones.
What happens if a supervolcano erupts? Here I choose Yellowstone as an example because I find that many people misunderstood the status of this supervolcano. The first thing we can expect is a huge disaster at a catastrophe level that can potentially cause major extinction. Buildings, agriculture, and climate will be greatly affected. It will be deadly. To support my point, here I present a paper by Mestin LG et al. That showed that Yellowstone is identified as a Plinian eruption type, making it one of the deadliest eruptions to happen. This paper showed that if Yellowstone were to erupt, the distribution of ashfall would spread to more than 2,000 kilometers upwind by using a model called Ash 3D, forming what we call an umbrella cloud. A powerful wide area umbrella cloud means that the ash spreading are less affected by atmospheric winds. The first picture depicts results of the simulation using Ash 3D. The blue shaded area is where an umbrella cloud takes form and is greatly enhanced by wind field. The picture on the right shows how further it can spread for months using wind fields, and we are expecting a global scale disruption. Hence, from this paper, we can conclude that it's not the explosion that we should worry about, it's the distribution of ash. This distribution of ash can travel for thousands of kilometers. The effects of this umbrella cloud itself can cause a global cooling that can last for a long time, and once it settles down to the ground, it will suffocate plants, affecting plantation as it is made of glass and tiny pieces of rocks, resulting in a possible global starvation. Not only that, ashfalls can block roadways, imposing serious respiratory problems and even damaging power lines. Air travel will have to shut down. Can you imagine how scary is that? But wait, before you start panicking, there is no need to start running up the hills because the chances of a deadly super eruption happening are fairly low. So far in the past, Yellowstone supervolcano had erupted about 3 times, where the first was about 2.1 million years ago, second one about 1.3 million years ago, and the third about 664,000 years ago. This is supported by the same paper which concludes that there are no signs for a super eruption to happen. So why is it low? Due to the North America tectonic plate moving southwest, this makes the hotspot beneath Yellowstone to slowly move northeast in the opposite direction, moving away from Yellowstone. We can note that with time, the hotspot will leave Yellowstone no longer posing a threat. And yes, considering that the hotspot is moving away, that might cause another deadly explosion elsewhere. However, this might take millions of years as the hotspot needs to heat up and melt the cool crust above it first. Co-author from the paper, Jacob Lowenstein from USGS, said that if an eruption was to happen, it won't be as catastrophic as we thought. What we can expect from continuous monitoring would be small eruptions. Also, scientists back up their stance on this by stressing the frequencies of eruptions here in Yellowstone, which are relatively rare. What erupted the most was smaller lava flows. The last lava flow eruption occurred in Pitchstone Plateau about 70,000 years ago. Because Yellowstone had a super eruption in the past, many people misunderstood that the catastrophic explosion might take place again in the future. All in all, scientists do not know exactly when this eruption will happen. They can only estimate and monitor the area for earthquakes and hydrothermal activities here in Yellowstone. These are my references that I used to present in this part. That's all from me. Thank you.
How to prevent a supervolcanic eruption? Or the real question is, can we prevent an eruption from happening? Now, the answer to that is actually no. However, there has been many ideas which has been set forth by researchers to prevent a natural eruption to occur. Now, one of these ideas actually came from NASA, and the idea is to pump cold water into a borehole, which helps the hydrothermal system to suck out heat and cools the magma, making it more sticky and eventually clotting it, preventing it from erupting. And there has been other ideas also, which involves depressurizing a magma chamber by drilling into it and thus relieving the pressure buildup. However, all of these ideas which has been proposed actually involves huge risks and they're super costly. What are the actual things that we can do right now? The first one is to monitor the volcanic activity through assessing seismicity by installing seismometers. Next, we should definitely check out for any deformations on the volcano. Look out for bumps or bulging, which may indicate that the magma has moved up closer to the surface. And lastly, check out for any gas leaks. By closely monitoring the volcano's activity and cross-checking it with its history of previous eruptions, we can actually predict when the next eruption is going to occur. Thus, experts can help out local authorities in making a thorough plan to minimize damage. Now, if you cannot find any shelter, then you should definitely move up to higher ground and definitely avoid all the valleys and low-lying areas to avoid lahars. It is crucial for you to shield yourself from pyroclastic flows. So, curl yourself up and protect your head with your arms. And most importantly, people should protect their nose and mouth by covering it with a mask or simply with a wet cloth, and also protect your eyes with goggles to avoid exposure from poisonous gases like sulfur dioxide, carbon monoxide, and many more harmful gases. Hopefully, with some of these survival tips, you can make it out alive.
A very good day to Dr. Lin and everyone who's watching this video. My name is Gugan and I will be presenting on the question of how will a supervolcano eruption affect Malaysia? So the first point would be drastic exposure of Malaysia's atmosphere towards sulfur dioxide and heavy acid rains. The perfect example to this situation would be the Mount Toba eruption that occurred 74,000 years ago. So during the eruption, the whole of Southeast Asia was covered with approximately 15 centimeters thick volcanic ashes mixed with thousands of tons of sulfur dioxide. When the sulfur dioxide mixes with water, oxygen and other chemical compounds, a very heavy acid rain forms. If this kind of similar eruption was to take place today, such acid rain would actually destroy our ecosystem significantly. Let's take a closer look. As acidic rain results in more aluminium absorption into the soils, this will be carried away into the lakes and streams, destroying any aquatic lives that lives under it. As the aluminium absorbs in the forest soils, the trees will have a hard time uptaking all these water molecules. Looking on the other side, humans with a prolonged exposure towards sulfur dioxide directly will develop asthma. Even prolonged exposure may actually cause damage to the brain and lead to death. If this does not already sound dreadful enough, we will be faced with even extreme consequences, which leads to my second point, global cooling. After the eruption, the ashes will circulate the atmosphere for years. As the thick layers remain at atmosphere, sunlight will be reflected away. This will result in the drastic decline of temperature. The worst case scenario that is comparable is again the Mount Toba eruption. During this time, volcanic winters lasted for decades. This will be a bad news not just for Malaysia but the whole world. To put this in perspective, back in 1816, the whole world faced a devastating event known as the Year Without a Summer that has caused famine and crop failures all over the world. This was due to an volcanic eruption at Mount Tambora located in Sumbawa, Indonesia. Now, to put this in comparison, Mount Tambora's eruption was only 150 km cubed. So, this has only brought the temperature to decline to about 1 degree Celsius. Now, imagine the Mount Toba's eruption, which was 2,800 km cubed. This almost caused the decline of 10 degrees Celsius. If such a drastic drop was to occur, there are very high chances that we will be entering into a new mini ice age. This, in consequence, may definitely reduce the human population if it lasts for decades. In a nutshell, the Malaysian population might be facing a genetic bottleneck due to the extreme food drought and environmental change. A genetic bottleneck can be easily described as when a population is greatly reduced in size, the genetic diversity of the species will be limited. So, as a conclusion, Malaysia will be faced by heavy and extreme consequences when a supervolcano erupts.